Hello. So in this video, I'm going to take class 9 chemistry chapter 4 structure of the atom. Before getting into the class, if you're seeing my channel for the first time, please do subscribe. Let's get into the class. So what are charged particles in a matter? It was known by 1900s that atom was an indivisible particle, but it contained at least one subatomic particle, which was identified by J.J. Thomson as an electron. Now, even before J.J. Thomson identified electron, E. Goldstein in 1886, while doing some experiments in gas discharge, he found that there were new radiations, which he called them as canal rays. Now, these canal rays, they were positively charged radiations, which led to the ultimate discovery of another subatomic particle, which he called as proton. Now, this proton had equal in charge, but it was opposite in sign of the electron, and the mass was approximately 2000 times that of an electron. So he named it as proton. Now in general, an electron we represent it as E minus and proton we represent as P plus. The mass of a proton is taken as 1 unit and its charge we take it as plus. Now mass of an electron we consider it as negligible and we give it its a charge as minus. It's seen that an atom was composed of protons and electrons mutually balancing each other. That we can see that in an atom, both of these protons and electrons, they're balancing their charges. It also appeared that protons were in the interior of the atom, whereas electrons could be easily removed off, but not protons. So we find that protons were inside or the interior of the atom, but more than that, more than of protons, easily we can remove an electron from the atom. So that's about the charged particles. Now let's come to the structure of the atom. Now, because of the discovery of these electrons and protons, that led to the failure of Dalton's atomic theory. Now, there was a need of how to explain the structure of atom consisting of these electrons and protons. So the first proposal of a model was given by J.J. Thomson. Now let's go to the J.J. Thomson's model of an atom. So what was J.J. Thomson's model of an atom? Thomson proposed that the model of atom is similar to that of a Christmas pudding. So he abstracted that to a Christmas pudding. Just like how in a Christmas pudding, dry fruits are, same way is the electrons in a sphere of positive charge they are embedded in that the electrons are embedded in a positively charged sphere of Christmas pudding. Now, second he explained was, like a watermelon. The positive charge atom is spread all over like the red part. The red portion that we eat, he placed them as the proton. And the electrons are embedded inside like the seeds of a watermelon. So this is how Thomson explained the model of his atom. So this is the Thomson's model of atom. So you can see the positive sphere and how the electrons are embedded in it. So this is how the Thomson's model of atom is there. Now, what all did Thomson propose? Thomson proposed that an atom consists of positively charged sphere and the electrons are embedded in it. So there's a positively charged sphere and the electrons are embedded in it. And the negative and the positive charges are equal in magnitude. So their atom is in neutral. That both of them have their charges are equal in magnitude. So the atom exists as a neutral thing. So this is the proposal made by J.J. Thomson. Now let's go to Rutherford's model of atom. So this is the second proposal of a model of an atom. So Ernest Rutherford was interested in very interested in knowing how the electrons were arranged in an atom. So he did a series of experiments to find how this is going to happen. So what was this experiment? In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. So what his experiment was that he made alpha particle, which was very fast-moving, he made them to fall on a thin gold foil. He selected gold foil because of a reason, because he wanted a thin layer. As much as possible, he wanted a thin layer. And this thin layer itself had thousands, it was 1,000 atom thick. So it was a thin layer, but still it had 1,000 atom thick it was. Now these alpha particles are doubly charged helium ions. So that's what's an alpha particle. Alpha particles are doubly charged helium ions. They have a mass of 4 units. So the fast moving alpha particles had a considerable amount of energy. So they were not of negligible energy. They had considerable energy. Now, What he expected was that the alpha particle will be deflected by the subatomic particles in the gold atom. Since the alpha particle are much heavier than the proton, he did not expect to see large. He expected some deflections to happen, but he did not expect very large deflections to happen because the alpha particles were heavier than the protons. But the experiment gave him a totally unexpected result. Let's see what. So this is the Rutherford model of atoms. So you can see the gold atoms inside the foil and the alpha particles going. So in this figure itself, you can see that most of the alpha particles just nothing happened. They got off easily. Some of the particles you can see they have been deflected by a small amount of angle, and some of them have rebounded 180 degrees. That, however, in the manner they come, they have gone the same way. So that's what Rutherford got. So these are the observations. Most of the alpha particles, they pass straight. Nothing happened, they gone straight. Now, some of the alpha particles were deflected by the foil by small angle. That they were deflected by small angle as we saw in the figure. Surprisingly, this was not expected by him. One out of every 12,000 particles appeared to rebound. So one out of 12,000 particles, they rebounded in the manner they had come. So this was an unexpected result that he got. So these are the conclusions made by the alpha particle scattering experiment by Rutherford. What were them? Most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting deflected. So he concluded that most of the space inside the atom is empty. That's why most of the alpha particles did not deflect or nothing happened. That's why. Now, very few alpha particles are deflected from their path, indicating that the positive charge of the atom occupied very little space. So, since very little particles were deflected from their path, he concluded that the positive charges were occupied in one of the center of the space, that it occupied very small space. Now, thirdly, a very small fraction of alpha particles were deflected by 180 degree, indicating that all positive charges and the mass of the gold atom were concentrated in a very small volume. So 180 degree, it oriented back. It tells that the most of the mass of the atom is concentrated in the center of the atom. Also from this, he calculated that the radius of a nucleus is about 105 times less than the radius of the atom. So we also found out the radius of the nucleus. So what is the nucleus is explained in this. So this is the his proposals that we can say. So there is a positively charged center in the atom. It's called the nucleus. So he named a nucleus, which is the positively charged center inside the atom. All the mass of the atom is concentrated in the center of this nucleus. The electrons revolve around the nucleus in a circular path. So the electrons, they revolve around this nucleus in circular paths, just how the planets are revolving in our solar system. The size of the nucleus is very small as compared to the size of the atom. So the size of the nucleus is very small as compared to the atom, as he found that the radius of the atom is 105 times smaller than the size of the atom. So this is the conclusions or the proposals or the postulates given by Rutherford. Now, what are the drawbacks of this Rutherford model of the atom? Now, he said that the revolution of the electron in a circular orbit is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron will lose energy and finally fall into nucleus. If there were so, the atom would be highly unstable and hence matter would not exist in the form that we know. We know that atoms are quite stable. So atoms are quite stable. So that was a very drawback that Rutherford's model had. So this is the Rutherford model. Now, this Rutherford model, this can be asked as a 5-mark question because we have this one drawbacks of Rutherford model. What were the postulates of Rutherford model? What are the conclusions made by Rutherford model? What are the observations made by Rutherford model? And what is the experiment of Rutherford model? So this can be asked as a 5-mark question because there are 5 elements inside Rutherford's model of atoms. So this can be asked as a 5-mark question. So that's about Rutherford model. Now we come to the last model of the atom. That's the BOHR'S model of atom. So this gives us a more clear picture of what an atom is. In order to overcome the objections raised against Rutherford model of atom, Niels Bohr put forward some postulates. So let's see what they are. Only certain special orbits known as discrete orbits of electrons are allowed inside the atom. So there are specialized orbits where the electrons revolve. While revolving in discrete orbits, the electrons do not radiate energy. While they are revolving, they do not radiate out energy. Now, these energies or shells, we call them as energy levels. And the orbits, they were also called as shell. Now, they were represented by letters K, L, M, and it goes on. Or we can represent that as numbers. It also are represented as numbers. N is equal to 1, 2, 3, 4. It will go on. So this is how Bohr explained his atom. So this is how that there will be a center of the atom, which is the nucleus, where the protons will be held. Now, the first shell is called as the K shell, where we write the number as 1. The next shell will be L shell, M shell, N shell, and it will go on considering how the elements go on. So this is the Bohr's model of atom. So that's about Bohr's model of atom. Now we come to neutrons. So in 1932, J. Chadwick discovered another subatomic particle which had no charge and mass nearly equal to that of a photon. It was eventually named as a neutron. So he found out that there was a particle which had no charge but mass nearly equal to proton. So he named it as neutron. Now neutrons are present inside the nucleus of atom except hydrogen. So except hydrogen, all atoms have their neutrons present inside the nucleus. So when we write the mass of an electron, therefore we give the mass of an electron as the sum of mass of protons and the sum of mass of neutrons. So the sum of neutrons and protons will give the mass of the atom. So that's about neutrons.